Hello everyone, welcome to Electron Tech channel. We are going to see FIR filter design using rectangular window. Here a problem is given. In this problem, we have to find the frequency response and the filter is the low pass filter. The frequency response is given capital HD of e power j omega and it is the desired frequency response. We have to find the filter coefficients h of n. Window function is also given. This window function is a rectangular window. We have to find the frequency response capital H of e power j omega. Step is we have to find the desired filter coefficient function. Capital HD of e power j omega is the desired frequency response. It is given. Here small d is the desired. Now we have to find the coefficient, that is small hd of n, that we can call it as desired impulse response coefficient or Fourier coefficients or filter coefficients. To get hd of n, we can apply inverse Fourier transform on given capital hd of e power j omega. We can find the desired filter coefficients by using this formula. Here we can substitute the given capital HD of e power j omega. Omega value minus pi by 4 to pi by 4. The HD of e power j omega is e power minus j2 omega. Here there are two exponentials given that we can combine. J omega is common in the powers of exponential, so we can take it outside. Now we have to integrate by using the formula integral e power nx dx is equal to e power nx by n. Here n is a constant. In our equation, j n minus 2 is a constant. So that is coming to the denominator. We have to simplify. We can substitute upper limit pi by 4 and lower limit minus pi by 4. Now the obtained equation is similar to e power j theta minus e power minus j theta by 2j. So we can convert it into sine form. We got the desired coefficient function. Then as a next step, we will find the values. First let us find the value for n is equal to 2. Because it is a special case, here 0 by 0 will come. Now let us see. 1 by pi 2 minus 2. In the denominator we have 2 minus 2, that will become 0. Then sine 2 minus 2, that will also become 0 because sine 0 is 0. So the answer is 0 by 0. Actually this is an indeterminate form, so that we can use L'-Hospital rule. The rule is limit theta tends to 0, sine n theta by theta is equal to n. Here n is a constant. So in our problem, n is pi by 4. So we can substitute pi by 4 and we have 1 by pi also. So our answer is 1 by 4. Now we can find the remaining values of hd of n. In the place of small n, we can substitute 0 so that we can get hd of 0. Similarly, we can find some other values up to hd of 1. Step is we can find the filter coefficients using rectangular window. H of n is equal to hd of n into WR of n. WR of n is the window function. W indicates that it is window. Suffix capital R indicates that it is a rectangular one. Now we can find the h of n values by substituting the n values. If we substitute n is equal to 0, we can get h of 0. Similarly, we can find some other values. Actually, this filter is a symmetric one, so that h of 0 will be equal to h of 4. Similarly, h of 3 will be equal to h of 1. Already we got h of 2. Next step is we can find the transfer function of the realizable filter. This is the equation. Here we can expand the small n from n is equal to 0 to capital N minus 1, that is 4. Already we have the values h of 0, h of 1 and so on. We can substitute that values and we can get h of z. Step is we can find the frequency response. Formula is given. We can substitute the values h of 0, h of 1 and we can get the frequency response. Thank you.